proper stand is not available. So please try to understand. If it will not be visible, please convey me through the message. So please concentrate the topic. So you must understand the meaning of this word, powder metallurgy. Friends, this is one of the manufacturing process. Try to understand. Powder metallurgy is one of the branch of metallurgy, and it is one of the manufacturing process. Means with the help of powder metallurgy, you are going to produce the components by using metal powder as a raw material. Not only metal powder, but also metal as well as non-metal powders can be mixed. I repeat once again, powder metallurgy is one of the manufacturing process like casting, rolling, forging, extrusion. How these are manufacturing processes, same way powder metallurgy is one of the manufacturing process. So what we are going to cover in this topic, we are going to cover how components are produced with the help of powder, how to improve their properties, what are the steps in manufacturing of the component with the help of metal powders, and then what are the applications of it. And at the end, some 3 flowcharts are there. Out of 3, definitely 1 flowchart is asked in the examination every time. So that 3 flowchart means sequence of manufacturing process of these 3 components are going to be covered in this topic. This is a very short topic. I think from Monday, once again, your test series are going to start. So by tomorrow, we can finish this topic, no issue. This is the small topic in the subject metallurgy, and the weightage of this topic is, in MCQ it is asked, no problem, for 1 or 2 marks. Compulsory 1 flowchart for 4 marks, it is asked. And maybe some of the sub question may be asked, what are the different methods of powder manufacturing. So 4 for 8 and 1 or 2, 8, 10 marks may be there. But you have optional question, that's why out of 3 you have to solve in 2 questions. But if you see, we have only 6 topics, so there is no question of leaving any topic. You have to study all 6 topics to get out of what marks. Let us concentrate on the powder metallurgy. So how to define it? Powder metallurgy is, or significance of powder metallurgy is, it is an art. It is an art of producing metal powders and producing the serviceable products from these powders. So how the definition covers producing powders? Because powder is not a thing which is readily available in the market. What composition you want, that powder you have to produce. Whatever part you have to whatever part you are going to manufacture, once you know the composition of that part, separately, if that part have 3 elements, A, B, C. So A powder, B powder, and C powder, you have to make it available. Okay, and then you have to mix it, then you have to compress it, and then you have to heat it, and then you have to use it as the serviceable object. So these are the different steps. So I repeat the definition once again. Powder metallurgy is nothing but, or deals with producing metal powders and converting or producing the products, serviceable products, by using these metal powders. Now only metal powder is not limitation of this powder metallurgy. What is the difference? See, if A and B elements you are going to produce and by casting, so definitely you have to consider its solubility limit. For example, aluminum's melting point is 660 and tungsten's melting point is more than 2500. So if you want to produce alloy with aluminum and tungsten, very crucial care you have to take, because and it is very difficult to produce or mix the molten aluminum and molten tungsten into each other, because at 2400 or 500 degrees Celsius temperature, aluminum will vaporize because its melting point is 660 only. So how can we make it possible? How can make combination of these elements possible? So we can make combination of these elements possible by powder metallurgy. You can take aluminum powder, you can take tungsten powder, and you can mix into each other. So not only metallic powders, but also you can produce part with metal as well as non-metal. So this is one of the project you can take it for your work. You can produce your metallic powders, whatever process I am going to explain. From this, you can develop your process and produce the small component with the help of this powder metallurgy, and you can check its strength, etc. So this will become one of the project for you. I told during heat treatment, this induction hardening. So small projects I'm telling to you, so that you can develop your ideas in this regard and you can continue it as a project work. Then I have told project work in the terms of induction hardening, table work. You can produce the coil and etc. Second thing I told, this powder metallurgy you can go for project. Then some extra thing I told regarding NDT, as you can go for courses and you can develop your own skill by cracking the level exams. All these other than syllabus, whatever I am telling, you're supposed to note it somewhere so that you can recall afterwards and you can start thinking on it once your exam is over. So remember this. So powder metallurgy chapter covers the methods of powder. I'm telling the contents of the chapter now. Powder metallurgy chapter covers the production of metal powder, how it is produced. Before that, we'll see applications of the powder metallurgical components. Then we are going to see the steps in powder metallurgy, how the components are produced. Then each step will be explained, and then we are going to see how the flow chart is done. So before we go to the different steps, let us start with the applications. Where this, you can't imagine, if I will show you the component. See, this is the component made up of powder. So you can see it as solid, as like produced by casting. Until and unless you will not see it by your naked eyes. I repeat once again, if I show some component, some automobile component, clutch plate, connecting rod, I will show you in the, or gear. And if I show you the gear and if I tell if this gear is manufactured by powder metallurgy, you can't imagine it, how it is possible, because it is looking like as it is casted and machined. No doubt, if you want to identify the powder metallurgical product, you can't see by naked eyes, you have to see under microscope. So powder metallurgical component shows little porosity. You can identify this is powder metallurgical manufactured component. As far as the strength and stability is concerned, they are having good strength, equal strength as like casted product. So this is the beauty of this manufacturing process. So where are the applications of powder metallurgy? Powder metallurgy find applications. I will dictate. Just wait. Powder metallurgy find wide applications in high temperature, then automotive application, automotive application, then aerospace, high temperature applications. High temperature applications means what? See, there are many elements like tungsten, then you can see atomic energy. One more is remaining, atomic energy. So I was telling about high temperature application. High temperature application means refractory materials, tungsten, tantalum, molybdenum. What is there? So these parts are used in the area where the part is exposed to higher temperature. For example, X-ray tube, cathode and anode. All these elements have to withstand there at that refractory. These are called as refractory. Meaning of refractory means which can withstand higher temperature. So for withstanding the higher temperature, the capacity of the metal should be also more. And how can give shape to the components? So casting of this component is very difficult. So pouring the 2500 degrees Celsius part about metal. So producing these shapes by casting method find little difficult. So instead of that, the metal powders are made available, and with the help of metal powders, the components, anodes, X-ray tubes and other parts of that X-ray tubes are produced. So wherever you find high temperature application, some components are manufactured by the products are manufactured by the metals such as tungsten, tantalum, molybdenum. So these elements are used for producing the part. Some shape is to be given, So that manufacturing is carried out by powder metallurgical process. So that's why it is called as application of powder metallurgy in producing the components. So I repeat, application of powder metallurgy in producing the components used at higher temperature. That is meaning of high temperature application. Now automotive, I already told, gears, conducting rods, clutch, friction materials, bearings, number of parts are produced by powder metallurgy. Second is automotive application. Aerospace. You must know that currently our space organization is ISRO and US space organization NASA. So number of satellites we are sending in the space, how they run, on which fuel they work. See, once they will get settled in the orbit, no issue. They are going to rotate it. But for making that part to reach there, some fuel is required to burn. And at such cases, your regular petroleum and gasoline products will not work. That's why, for your kind information, metallic powders are used as a fuels. Metallic powders, one of the best application is magnesium, beryllium, zirconium, aluminium. These metallic powders are used as a solid fuels, and these solid fuels will take that satellite in the rocket into the orbit. So these powders are produced. So powders are produced means it is related to powder metallurgy. That's why this application of powder metallurgy. And then last one is atomic energy. So what are the beryllium and zirconium powders are there? They are used for making the control rods. Beryllium powder and zirconium powders are used for making the controlled rods in the nuclear reactor. You have seen the nuclear reactors. So there are control rods, and these control rods are made by beryllium and zirconium. So how they are made? So beryllium powder is produced, zirconium powder is produced, and with the help of compacting and sintering, the components are produced. So these are the, there is no limit. So any maximum areas, the parts are produced by powder metallurgy, depends upon the requirement. Now where to use this part, where not to use this part, what are the limitations of this part, all that will cover in due course of bits when we will cover. Okay, write down definition of the powder metallurgy, write down. Powder metallurgy deals with production of metal powders, and manufacturing of products with the help of these powders. Next line. It is an art of producing metal powders. It is an art of producing metal powders and using them to make serviceable objects. Next line, applications. They are written on the blackboard. One by one you write. First, high temperature application. In bracket, refractory metal powders are used. For, in bracket, refractory metal powders are used, in bracket, tungsten W, comma molybdenum, MO, comma tantalum, Ta. Refractory metal powders are used for electric bulb filament, X-ray tube, comma radio wall, in the form of, okay, no, don't write in the form of radio wall, etc. Next line. The metal powders are also used for producing. Cutting tools, comma forming dies, DIE, forming dies used at higher temperature. So imagine tool is made up of powder. How strong the tool will be produced even it is made up of powder. So you can't even maximum. You have seen the CNC, which is our in our college. You might have visited a workshop. You have seen in the industry also. So whatever cutting tips are there, all tips are manufactured by powder metallurgy. The application itself is carbide tool. Carbide tool is one of the application of powder metallurgy. Okay. Next, second, automotive application. Brakes, comma clutches, wipers, comma crankshaft, comma connecting rod, comma porous bearing, crankshaft, connecting rod, porous bearing. One thing I will tell, so as a mechanical engineer, these three words which I am telling now, one is crankshaft, another is camshaft, and third thing is connecting rod. So many students get confused in front of the interviewer. We explain what is crankshaft, what is camshaft, and what is connecting rod. You know better. Okay. But many times you get confused. Next person is asking camshaft and you are talking about crankshaft. And connecting rod is added or different. So write it somewhere. So please clear your concept regarding camshaft. So cam and follower is used. That is the camshaft. So precision camshaft is at Solapur. So all camshafts are produced there with the help of casting method. That camshafts are also manufactured by forging. But in Solapur, precision camshaft is producing it by casting. Then crankshaft is different and connecting rod is different. So these three which are not related to our subject, but you have studied it. You write it somewhere and clear your concept regarding it. So all these components are made up by how they are made up of casting, then forging. Similarly, powder metallurgy is also one of the application for producing it. Just remember it. Next, aerospace application. The solid fuels used in the aerospace are nothing but mixture of nothing but mixture of mixture of beryllium, aluminium. Just write short form B, Al, beryllium, aluminium, magnesium, Mg, zirconium, Zr, powders. So imagine these powders are, see, even you might have seen the firecrackers during Diwali festival you have seen. So in Marathi we are calling it Jhad. So if you find it defective, you just break, open it, in whatever the material, burning material you are going to see it. आपण त्याला दारू म्हणतो in Marathi, उडवायची दारू. So you will find small pieces of the magnesium there. Just check. Because of that presence of magnesium, it gives some burning colors. Just for your kind information I have told. So these are the applications of powders, metal powders in the aerospace. Next, fourth, atomic energy. Atomic energy. Next line, beryllium, zirconium. Beryllium, zirconium powders are used for manufacturing control rods in nuclear reactor. Control rods in nuclear reactor. This is all about the applications of powder metals. Steps in the powder metallurgy. One by one you write the steps. Powder production. Am I audible? Somebody reply. Am I audible? Okay. So write down. First is powder production. Second, mixing, blending. Mixing, blending. These are the steps in powder metallurgy product. So what are the steps in casting? 1, 2, 3. So pattern making, then core making, molding, so core box making, then molding. In that way, same way, how to produce the part by powder metallurgy, there are the steps. And each step in detail we are going to study. So first is powder production. Second is mixing and blending of the powder. Third is compaction. Compaction means pressing. Fourth is sintering. Sintering, S-I-N-T-E-R-I-N-G. Sintering. And fifth one is inspection. So powder production, mixing and blending, same. Powder production, mixing, blending, compaction, sintering, and inspection. Every powder metallurgical product is manufactured by following these steps. Okay. Now, let us see one by one. I already told I want to produce some component with the help of suppose copper, tin. These two powders are there. I want to produce some component. One. Then, in that case, those may not be available. In that case, the copper powder, tin powder, if it is available in the market, you can purchase it. But if it is not available in the market, it is to be produced. It is to be produced by you. And then how to produce it, that methods are explained in the powder metal. Just 1 minute. Huh? So these powders are produced by powder production method, powder making. So there are different types of powder production. In detail, we are going to study after explaining these points. So how to produce metal powder? Again, 1, 2, 3, 4 types are there. So you can't produce this it for any one element. You have to follow that particular method to get good quality of powder. Okay. Now, second thing, once powder is available with me, I have to produce the component from it. So I have to produce the component from it means I have to produce the solid component from it. I have loose powder with me. Then these powders are to be bonded together. For that purpose, some lubricating oils and other parts are to be there, and there should be uniform mixture of the 2-3 elements. If you have taken A, B, C element, and if any bunch, so if I will take spoon, I have produced 2 kilo of powder, and I will take 1 spoon powder through it. So the combination should be common. If I have selected 90:10 proportion, and if I will take that everywhere, that composition should be common. So to achieve everywhere common composition, it should be mixed properly. Complete mixtures are used, and then proper mixing of the powder will be carried out. Third step is compaction. You have to shape it. You have loose powder. You have to give shape. So if your shape is complicated, your die may not be that complicated. You can produce simple block first, and then you can machine. Very simple. The piston and cylinder arrangement is there. In that piston cylinder arrangement, you have to put that powder and press it. Imagine you are going to press it to such a high pressure so that these 2 particles of the powder will join together by solid welding. You can do an experiment. So you take this wet soil. अशी ओलसर झालेली माती असते की नाही, खाली पडलेली, चिखल नाही, ओलसर माती. ती माती घेतली आणि त्याशी घट्ट हातामध्ये दाबली आणि सोडलं तर तुम्हाला त्याचा एक गोळा झालेला दिसेल. सेम मेथड. But you can't take metal powder in hand. You don't have that power. So power is to be produced with the help of machine, and with high pressure, the powders are compacted so that it will take the shape. Usually simple blocks are produced, and later on you can machine it. So now whatever part you have produced by compaction, you will get the solid part from the powder. But that is fragile. Fragile म्हणजे ठिसूळ, नाजूक. त्याला परत असं थोडं ठोके दिले किंवा दाबलं तर ते परत तुटेल. त्याने जस्ट आता शेप घेतलेला असतो. पण तो शेप टिकवण्यासाठी त्याच्यामध्ये ताकद यायला पाहिजे. सो यू हॅव टू गिव्ह स्ट्रेंथ टू दॅट कंपोनंट. That component is called as green component. You have studied green molds. Green म्हणजे कच्चा, which is having less power, with less strength, not power, sorry, I will take my word back, which is having less strength, which is fragile. So that fragile components are, if you are going to give strength to it, it must be fired. कच्च्याला पक्का कसं करतो आपण? फायरिंग करून. Same thing. Sintering is one of the heat treatment. You have studied number of heat treatments. So sintering is specially used for powder metallurgy. So if you Google it, you will find sintering companies. So Mahindra Sinters. Try to imagine. Mahindra Sinters means that company is using powder metallurgy for making some components. So such many sintering components, names are given sintering, but they are powder metallurgy components. So sintering is one of the heat treatment which is used for giving strength to the compacted product. And once you give the strength means you have to heat, soak, cool. Heat treatment I already taught you. Heat treatment is nothing but heat, soak and cool. Heating, soaking and cooling. So in this way, the fragile components are converted into the product which will develop sufficient strength after the sintering. What exactly happened in the sintering? That in detail we are going to study. So metal bonding increases strong, and if the component is having less melting point, if there are 3 components out of 3, if one component is having out of 3, if one component is having less melting point, that may get melt and produce the bonding between remaining 2. And then inspection. So these are the steps in powder metallurgy. This is classification. Now I will explain you methods of powder production. Go to next line and write down classification of powder production. So many times this question was asked in the paper. Many times. What are the methods of powder production? Okay. Whether I am audible? Whether I am audible? Okay. So powder production are on powder production. Number of questions are the same question was asked number of times in earlier examination. So what are the different classifications of powder production? How to produce the metal powders? Okay. So write the classification. There are 4 types: mechanical, physical, chemical, and electrochemical. Mechanical, physical, chemical, and electrochemical. Again, we will give further classification of it. I will explain it. Just first write down the chart of classification. condensation, thermal decomposition. These two are the types of physical method. Third, chemical reduction and precipitation from aqueous solution. Aqueous solution and electrochemical. Make it fast. Is it over? Please reply somebody in chat box. Is it over? Hello? Machining, crushing, milling, sorting, atomization. I repeat, machining, crushing, milling, sorting, atomization. Physical methods, condensation, thermal decomposition. Chemical reduction, precipitation from aqueous solution, and electrochemical. Now, today I will explain you mechanical methods. And remaining methods will explain tomorrow because only 10 minutes are remaining. Pay attention now. Please pay attention. May I erase now next part? Please reply. May I erase this? Hello? Now see here. Pay attention. Mechanical methods of powder production. Machining. You know that you are, see, earlier you have studied that you are going to do turning, you are going to do drilling, you are going to do facing operation in the turning, you are going to do reaming, you are going to do milling. Number of operations in the workshop you have seen. Grinding, all these are machining operations. So you are going to machine your component, you are going to throw your component, throw your scrap away. So this scrap which you are going to throw away is our main material. So intentionally you do machining. What material you want? Shape of the component is immaterial. You just go on machining it and take the raw material in the terms of chips. Okay. So depends upon it. How much is the size? So you know that grinding will give fine particles directly, but it will take long time. If I want to produce powder with the help of this complete rod, and if I will go on grinding, it may take 1 month. Slowly it will get removed. So instead of that, I will go on turning it. I will produce the chips from it. And then these are pulverized. Dalne. You are going to crush these chips directly, and by crushing of these chips, fine powder of the metal or alloy, whatever may be, is produced. So simple, making available powder by machining process. Whatever scrap is available, you have to pulverize or you have to crush, and you can get powder available. That is meaning of machining. If your component is brittle, so I have this component. If I will put it, if it is ductile material, and if I start pulverizing, it will not get pulverized or crushed easily because of its ductility property. It will deform. But if it is brittle, I can crush it directly. Brittle components चे तुकडे तुम्ही भुगा लगेच करू शकता. So crushing is directly method for the brittle materials. Directly you put the pieces of the cast iron, steel, whatever may be, in the pulverized mill and go on crushing. So crushing will produce fine powder from the required metal. Milling. Now this milling is different than your machining milling operation. This milling word is different, and whatever milling operation in the machining, that is different. What is this milling? Milling means mill. Mill म्हणजे आपण मराठीत गिरणी म्हणतो. Ball mill, then roller mill. पूर्वी जुना शब्द आहे mill कामगार. It is that mill. So different mills are there in the terms of a big drum, and in that drum crushing is carried out. So this drum may be like this, and then it is kept on the rollers, and it is made to rotate. So when you are going to make it to rotate, this drum is kept with pieces of metal or alloy along with hard balls. I will hatch these balls. This is ball mill. So these are the hard balls. This drum inside surface is hard, maybe of white cast iron or other steel. These balls are also hard, and along with it you are keeping the pieces of the metal which you want to make crushed, which you are going to crush it. How it works? So if you rotate it, there are three options. If you rotate it, there are three options. Which three options? Suppose I will rotate it with very slow speed. Very slow speed. What will happen? Due to inertia, this all material will be at the base. म्हणजे काय होईल, एकदम हळू फिरवल्यावर ते मटेरियल तिथंच राहील आणि नुसतं सिलेंडर फिरलं जाईल. Yes, I will rotate with a very high speed. What will happen? Because of centrifugal force, this ball and material will crushing होणारच नाही. There will not be crushing. You have to rotate this drum with critical speed. What is critical speed? It is the speed at which these balls will lifted up and fall down. म्हणजे बॉल असे वर उडी मारून खाली आदळले जातात. ज्यावेळी हे हार्ड बॉल वर उधळून खाली आदळतात, in that case the material get crushed between ball and the surface of this drum. The material get crushed between two balls as well as material get crushed between ball and the surface of drum, and in this way you can produce fine metal powder. This is the milling operation. This is figure of ball mill. You can take screenshot of it. Okay, later on you can draw the figure. This is one ball mill. And now, friends, last two types of mechanical method are very important, because these two types includes melting of the component. Melting. Earlier there is no melting. So these last two one consist of melting. Now you say once melt is produced, what to do with that melt? We can cast it. No, but we want metal powder. Shorting method. The best example in your day-to-day life of shorting is bundi padne. Local example I am telling. So that raw material is taken and put on the sieve. In Marathi it is called as zarya. And that material you are going to pour, and you will find the small droplets will fall in the boiling oil. Okay. Same way, there is one sieve, and on that sieve from particular height, the molten metal is poured, and molten metal will fall on the ground as a droplet. Molten metal will fall on the ground as a droplet. Okay. And then later on these droplets, वाळू सारखी खडे होणार त्या मेटलचे, and then it will be taken and it will be pulverized. So this method is called as shorting method, which is not suitable for the parts which have highest melting point. It is not suitable. Okay. So shorting consists of producing the metal powder by melting it and passing it between the sieve and make it to fall from the top. वरून खाली पडताना ते सॉलिड होऊन पडतात, हवेमध्ये गार होतात छोटे छोटे साईज असल्यामुळे. ठीक आहे. In that case, after getting that solid parts, that will be pulverized to produce fine powder. Atomization. The atomization means it is not automatic word is different. Atom च्या related आहे, म्हणजे लहान साईज. Atomization means it is indirectly शब्द वापरला असे, we can say उपमा दिलेली त्याला. So what is this atomization? You are doing one experiment in your childhood. Somebody may be making now also. Whenever you are going to brush in the morning, early in the morning you are going to brush. So at that time what you are doing? You are going to take the water in your mouth and you are supposed to take it out. In Marathi we call it as chul burning. If you'll do it with less pressure, there will be jet. हळूच जर सोडलं पाणी तर ते जेट प्रमाणे पडतं. And if you take air in mouth like this and along with the air, if you throw water outside, what will happen? फवारा उडतो, फवारा. So it is फवारा. Okay. So molten metal is passed through the nozzle with compressed air. I repeat once again, molten metal is passed through the nozzle with compressed air. And it will go in the air in the terms of sprinkles, fawara. No doubt, as soon as it will go in the air, it will convert into solid and fall on the ground as a particle. And then it will be collected together and it will be pulverized. So this is atomization. Machining, crushing, milling, sorting and atomization, these are mechanical methods of producing the powder. Remember it, these few lines I will dictate in the next class. Just wait, I will take attendance. We will stop here. Thank you.